Guys, welcome to lecture number 2. In today's lecture, we have already discussed equations of uniformly accelerated motion. So we will be covering the concept and we'll be discussing how to actually apply those equations of motion in real life. We'll be doing questions regarding the horizontal motion. We'll be doing questions regarding the vertical motion. And then we'll conclude this lecture over here, and then we'll be doing the how to apply these equations in the concept of finding gravity. That is the topic for the next class. Okay. First of all, you need to assume that all these examples are uniformly accelerated motion. A lot of the times this question comes up that you have given a situation in which usually in the MCQs, the object is moving at 40 meters per second. They have given the displacement. Object is moving again at 20 meters per second, and they have given the final speed of the object. Eventually it came to rest, and this displacement is unknown. You need to realize if this is a uniformly accelerated motion, that means acceleration is going to stay the same throughout the whole thing, throughout the whole journey. And then you would realize what can be used. So yes, first of all, you will write SUVAT. This concept that you have to first consider this part of the journey is very important. That whenever they have given you a journey in which it's going on, there are two parts to it. First of all, you have to consider a journey in which you have got multiple information given. If I look at this part of the journey, I can see I've got initial final velocity, I've got displacement. So, and from here I can first of all calculate acceleration. So I've got S, I've got U, I've got V, I need A. There's no need to get time, so time is not important. I'll be using from these 4 equations of motion that I'm pretty sure that you remember by now. I'll be using the second one, that is V square minus U square equals 2AS. Why? Because I need acceleration. I've got all other 3 things. I'll be using V square minus U square equals 2AS. Final velocity 20 squared minus initial velocity is 40 squared equals to acceleration we need to find, and the displacement is going to be 60. From there I can calculate the acceleration value. That will be negative 10 meter per second square. This negative 10 actually indicates since we are decelerating and the velocity is decreasing, so we have got acceleration as negative 10. Okay. Now, for the second part of the journey for which I need the displacement, I can actually safely say that acceleration is going to stay the same. So for the second part of the journey where I need the acceleration, I am going to be applying the equation. Again, I'll write SUVAT. Just to make your understanding, I usually don't like writing this, but okay. S is unknown, initial velocity is 20, final is 0, acceleration is negative 10, time is not needed. Again, I'll be applying V square minus U square equals 2AS. The final velocity in this case is 0. Initial is 20 squared equals 2 times negative 10 times S. So 20 squared is going to be negative 400 is equals to negative 20S. So negative 400 divided by negative 20 would give me the displacement value, and that would be equal to 20 meters. So this is it for the first question, the horizontal journey. So yeah, this is pretty much everything, 20 meters. Well, I hope this makes sense. Let's do one more. Okay. In example number 2, it's a very similar situation. I've got displacement for the first one. You can pause the video, try doing it. I hope you have paused it. Let's start doing it. Okay. So I've got a journey in which, again, I've got very similar situation. I've got final velocities. I've got all the velocities. I need this displacement. Again, SUVAT. First, I'll be using the first part of the journey. In the first part of the journey, I have got a displacement, that's 40. I've got initial velocity 0, final velocity 15, acceleration is unknown, time is not needed. So I'll again be using v square minus u square equals 2as. V square is 15 squared minus 0 squared equals 2. Acceleration is supposed to be found and displacement is 40. So 15 squared and answer is to be divided by 2 times 40, in which I'll be getting 2.8. So acceleration will be 2.8 meter per second squared. Yes. All right. So yeah, and then since I've got the acceleration, I can use SUVAT again to find the velocity. V square minus u square equals 2as. For the second part of the journey, you will realize that final velocity is 30. So 30 squared minus initial velocity is 15 equals 2. Acceleration I just calculated, and now I need the displacement. So it'll be 30 squared minus 15 squared, and the whole thing is to be divided by 2 times 2.8, and from there I'll get the displacement value to be 120 meters. So this will be 120. So this is some very basic understanding of how to actually apply the SUVAT equations. This was the horizontal motion. Now I'm going to be moving on to the vertical motion. Kids, when it comes to vertical motion, the questions are not that simple. There are multiple examples that we have to discuss in slowly so that we can understand everything. First of all, if they ask you that the ball is dropped vertically from rest, travels a displacement of 40, calculate the time to reach the ground, and calculate the final velocity before it hits the ground. A lot of the times you need to realize if the ball starts from rest, this means that initial velocity is 0. And in this question, mostly they will be giving you that air resistance is negligible. Kids, you have to be very, very vigilant, and you have to now know that if something is being dropped in air without air resistance, it is your next truth that the object would have acceleration which will be equal to the acceleration of gravity, which value is going to be 9.81. So what we just discussed is during a vertical drop with no air resistance, acceleration will always be equal to gravity, which will be equal to 9.81 meter per second square. Whenever something is being dropped in air, you have to actually understand that the particular object is going to be dropping with acceleration that will be equal to 9.81, which is equal to acceleration due to gravity. So if there's a ball that is being dropped, you would actually realize that this ball would have acceleration that will be equal to 9.81. All right. First, in one part, I need the time to reach the ground. So yeah, I would be using SUVAT. I've got S, that's 40. I've got initial velocities as 0. This is not known. Acceleration is 9.81 because it will be equal to gravity. And time, I have the time. No, I don't have the time. I need the time. Oh, sorry, I need the time. Okay. So what I will be doing is, I'll be doing S is equals to UT plus half AT squared. Now, there's a little bit more understanding to this. For all the equations in which initial velocity is 0, that means u is 0. So 0 multiplied by anything becomes 0. So this formula can be just written as half AT squared. I don't mean to actually make it more complicated. I just mean to make it like a little bit less complicated. So rather than S equals UT plus half AT square, you can use S equals half AT square. But that's not my recommendation. I would recommend to write it fully and then understand that why this becomes 0? Because the initial velocity is 0. So S will be equal to S I've got, that is 40. I'll be using the whole formula for now. 0 times t, that becomes 0 plus half. Acceleration is going to be 9.81 and then times squared. Okay. So 40 times 2 is 80, and then 80 is to be divided by 9.81, and then root the value. You would get the value of time, and the value of time would be equal to 2.86 seconds, which I can round it off to 2.9 seconds. That's going to be the first part A. Moving on. For second part, I need the final velocity before hitting the ground. So for B, I now have T, that's 2.86. I need V, so V is equals to U plus AT can be used. I need the value of V. I've got initial velocity already, that is 0 plus acceleration is 9.81, and I just calculated the time 2.86. So I can just multiply 9.81 by 2.86 and you can get the value of velocity, that would be 28 meters per second. So this is some basic understanding of a vertical drop that I think is very important. Okay, moving on. Now they're saying that a car is vertically upward and reaches the maximum height in 9.4 seconds. Calculate the initial speed and the maximum displacement. Okay. Now this is vertically throwing up. So I'm now throwing the object vertically upwards. And always remember, if something is, they would usually say the air resistance is negligible. Whenever something is vertically thrown upward without air resistance, you need to realize if something is thrown vertically upward without air resistance, this actually means that the object is going to have an acceleration that is going to be negative 9.81, or you can say negative g, because the object is going to be stopped by gravity in this part of the journey. So you need to realize that it's going to change in velocity is going to be now in negative because the velocity is going to be reducing. So the acceleration is going to be negative 9.81 meter per second squared. This is going to be the case when an object is thrown vertically upward, moving upward. Now, first of all, I need the initial speed. So initial speed is needed. I can just use SUVAT first. I know the acceleration is negative 9.81. Again, if let's say something is moving at 40, it would slow down 30, 20, 10. So that's why the acceleration is negative. If you have any confusion, please leave a comment or ask me. Okay. We have got the time, that's 9.4. We have nothing else, right? But no. One more thing that you need to realize, if something is thrown vertically upward from like going up, and at the maximum height, it always stops. If something is thrown up at maximum height, it always stops. So the final velocity in this case would be equal to 0. If something was dropping, initial velocity was 0. But if something is thrown up, don't confuse it. Just remember the concept. If something is thrown up, once it reaches its maximum height, the final velocity always becomes 0. First part, I need the initial speed. So I need u. I can use v is equals to u plus at. I need u. So v is 0 is equals to u plus acceleration is negative 9.81 and in time is 9.4. So negative u is equals to 9.81 times 9.4. That will be negative 92.2. Negative cancels. Initial velocity will be 92.2 meters per second. That will be as simple as that. All right. Second is I need the maximum displacement. So maximum displacement, very good. I need S. S is equals to, I can use any equation now. S is equals to ut plus half at squared. S is equals to initial speed is 92.2. Time I already have, that's 9.4. Plus half acceleration is going to be negative 9.81. And then time is 9.4 squared. You just plug everything in a calculator just to be sure. 92.2 times 9.4 plus 1 over 2. Acceleration is negative 9.81 and then time is going to be 9.4 squared. You would get a value of displacement that will be equal to 433 meters. You can write it as 430 rounded off to 2 SF. Okay. Now this is the basic understanding of the vertical throw. In the first lecture, we discussed the basics understanding of what to do. And in the second lecture, we are pretty much done with uniformly accelerated motion in one dimension for the starters. All right. There's one more question over here that I want you to actually understand is this one. Example number 3. Now, this is some very, very interesting question. And not all of us can do it, but okay. Stay very clear with me. A ball is released from rest through a height of 100 meters. Calculate the time taken for the ball to fall for the last 20 meters. I need the time for the ball to just traveling this part of the journey. So I need this time. The height of the whole thing is given as 100. Now, initial velocity is given as 0. Think about it once again. Have you thought? Now listen to me. For such a question in which you need a time for the last part of the journey or something, you actually have to first find the time for the whole journey. Then you have to find the time for the first part of the journey. Then subtract the whole time from the total, like the time before that, and then you can get the time for the last part of the journey. Because if you were to find this time directly, you don't have the initial velocity here, you don't have the final velocity here, you don't have the time here. So it's impossible to find that. How you actually going to be solving that? This is going to be the last part of this lecture. That's S is equals to ut plus half at squared. So S I've got to find, that's first is 100 is equals to initial velocity stays 0, so I don't need that. The acceleration is going to be 9.81 because it's falling under the influence of gravity. I would first get the time. Sorry, I did not write SUVAT, but I'm pretty much hoping that you understand what I'm doing. 9.81 and then root of answer. I would get the time. I used 100 and I got the time value to be 4.51. This is the time for the whole journey. This time total is 4.51 seconds. Second is, I get the time for the first 80 meters because the whole is 100 now. I can easily get the time of 80 because I've got initial velocity to be 0. I can just calculate the time for the first 80 meters. So I'll be doing that. Stay with me. Again, S is equals to ut plus half at square. S is going to be 80 now. Initial velocity is going to be 0. Half acceleration again under the influence of gravity. So 9.81. From there, I can calculate the time. This time would be 4.04 seconds. So it took the ball 4.51 seconds to do the whole thing, and then it took the ball 4.04 seconds to do the first 80 meters. If I just need this time, I can do 4.51 minus 4.04 and then 4.51 minus 4.04. I get the value of time to be 0.47 seconds. This is the time the ball took to travel the last 20 meters. Well, I hope you get the concept. That concludes for lecture number 2, the questions and understanding of uniformly accelerated motion. In the next lecture, we'll be continuing with motion. I hope you understand the concept. See you in the next lecture. Take care, guys. Hello guys, this is Sir Mahad Amer and welcome to another lecture. Since you're enjoying the lectures, just wanted to inform you that there are premium batches going on. That is a direct way to get A's and A stars. It has got some exclusive content that is not generally available neither on the website nor on the YouTube. So you can join the batch to get your grade.